Hello, everybody. Thank you so much for joining us today for our first sponsored event from JFrog. Yes, we're really excited about that. Let me introduce myself for those of you who don't know. My name is Abby. I work with Barry Cranford, who's the founder of the LJC, and I have the privilege of hosting today's event. For those of you who don't know, the LJC is just one of the communities that is run by RecWorks. We are a tech recruitment company with a massive difference. We believe that recruitment really can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. From our perspective, if people want to learn and others want to teach or share their knowledge, we are more than happy to connect you through our communities and events. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. To date, we have run over 700 different events for engineers and developers, students, graduates, CTOs. We have run conferences, lightning talks, hackathons, mingles, all sorts. In January, we made our 4,000th introduction through our Meet a Mentor program, and we're really excited to see where that's going to go next. As I've already said, we love to give opportunities for people to connect, and this event is part of that. If you would like to know more about any of our other communities, please do let me know, or Barry or Helen Lewis, and we can take it from there. Just to let you know as well, today's session is being recorded, so that will be available on YouTube through our channel. Look for RecWorks and you'll find it. Or if you want to, I will put my LinkedIn profile in the chat and you can ping me a message and I'll send you the video when it's ready. With no further ado, I'm going to hand over to Ari, who's going to tell us a little bit more about JFrog and something else exciting for you as well. And then we'll hear from Sven. Over to you, Ari.
All right, thank you so much, Abby. I really appreciate it. I'm going to share my slide for just a moment. It'll take the attention off the bad lighting in my background, but hi everybody. I am Ari Waller and I am the Meetup event manager for JFrog, and we're really honored to be a new 2022 sponsor for the London Java community. Thanks for having us. We're really excited about working with the team. Alicia, Jade, Abby, Barry, all do an amazing job, and we're just really excited to be part of your community, even though at least today it's virtual, but we hope to visit in person soon. I'll share just a little bit about who we are. JFrog is the DevOps software company. We were founded in 2008. Many people in the Java community know us best by our flagship product, Artifactory, which was written in Java and is considered to be by many to be the gold standard for managing your artifacts and dependencies. But there's something that many people don't know yet, and that's that JFrog has a free cloud version of our software available to you to use for your projects, especially for the Java meetup community. And if you're working with Docker, as I know many of you are, JFrog's free cloud version is capable of functioning as a pull-through cache for Docker Hub. And the best part is that since JFrog has partnered with Docker, you'll be exempt from their rate limits on pulls from free or anonymous accounts. In fact, on April 28th, you'll see an announcement soon coming from the London Java community. We do have a workshop planned for you by Melissa McKay, who will be going through that free software so you can use it for your own project. So keep an eye out for that. Another bonus, as you already can see, is our raffle just for attendees today. JFrog is going to give you a chance to enter to win a pair of AirPod Pros. And you can enter with the QR code or the bit.ly link that you see. And I'm also going to drop that in the chat in a moment. A winner will be selected within 2 business days, and then we will share the winner on the meetup page and through social media once the winner formally accepts the prize. Unfortunately, we can't do a live drawing over the internet, but we will contact the random winner, and they will, once they accept it formally, we are happy to announce it to the whole community to know that there is the winner. Now, there's also no losers today too, because anyone that enters the raffle that you see and is willing to provide their address and t-shirt size, JFrog is going to send you a free t-shirt. We have some really cool t-shirts. I'm wearing one of them. I'm not sure. I don't believe this one's available. Sven has one on as well, but you're going to get a really awesome JFrog t-shirt for your collection of technical t-shirts. And without any further ado, I am going to turn it over to Sven Ruppert, who's going to be sharing with us today. Sven, take it away.
Hello and greetings from Germany. So Yes, finally. So in the middle of the day, I hope you have some time for cool Java stuff. We're talking today about proxies, and what I'm talking about is based on a book I wrote long time ago together with Heinz Kabutz in the German area. And this is, yeah, quite old stuff, but good stuff, and it's cool Java stuff. So let's see. Okay, the first critical thing I have to do now is sharing my screen and making sure that I'm getting all the things back here. Let me try if I'm able to do this. So I think you should see my slides now. So please give me in the chat at least a ping if you can see my slides. And talking about the chat, so if you have any questions, then just write your question in the chat, and then depending on what I'm talking about right now, I will try to give an answer on the fly during the time we are at the same slide. So mostly this is more convenient than this Q&A in the back in the after the talk. So where some random questions A and B. I will be there if you have enough time for Q&A, don't worry. But if you have questions, please just feel free to put it in the chat. So now I'm searching for the chat window. So every time I'm starting screen sharing, Zoom is closing chat window and all this stuff. If someone of you knows how to get rid of this behavior, please let me know. I'm searching for it since 2 years now. Okay, so let's go. So proxy deep dive. So proxy is an old thing. And well, so by the way, my name is Sven Ruppert, and I'm developer advocate at JFrog, and I'm here from the German region. And since the pandemic, I'm mostly out in the woods. So instead of traveling to conferences, I'm starting, going to the woods again, what I have done during my childhood. And I started recording my talks in the woods. So if you like, cybersecurity stuff, DevSecOps stuff, or Java stuff in an outdoor style, then have a look at my YouTube channel. I have 2 of them. The first one is in German. The second one is in English. So make sure that you are subscribing the right one, depending on your language. And if you have definitely no need for IT stuff and you just want to have bushcrafting stuff or outdoor stuff, then look at my private YouTube channel. So this is our pet project, and I love it. And I'm happy for every new subscriber. It's so tiny, these channels, but I just love to work on this stuff. Okay, so proxy deep dive. The first steps. What I saw quite often is that people are mixing the word adapter and proxy, and this is why I starting with this, because I see this mix quite often, and this is sometimes not really good if you want to refactor or reuse this patterns. So the first thing, why we want to use proxies. So proxies is more or less, I want to have something that is somewhere. It could be based on different needs, and I want to make some generic abstract functionality available that is across different parts of the application. It could be something like managing resources. It could be some dedicated behavior in chains I want to add or remove. So you have different ways or different needs for proxies, but mostly it's more or less you want to divide things instead of hard binding them, and often you want to hide technical stuff so that you really can focus on the domain specific things. So, and proxies must be easy to use. I see so many proxy implementations that are cryptic in terms of how to use, how to initialize, how to read these proxies, and it would be nice if you have something like some class, and if you want, you start creating a proxy for this, and this proxy should be or you should have the possibility to add several features or behaviors, like adding logging or adding metrics or maybe some security rules or a bunch of them. And it should be in a way that it's type safe. It should be easy to use. It depends a little bit on the style you want to have. So it could be this this chained invocation. It could be some other style, but it should be easy for you. And it should be in a way that the creation of a proxy and the definition of a proxy shouldn't be definitely at the same time, or it should be in a way that you can define something and activate resource or use resources later. So what can we do? So this is more or less where we want to go through. And yeah, it would be easier if you have something like this, like annotation processing. If you like this one, for example, that you can mix it with different technologies like dependency injection, and then you are adding some information like, I want to have a virtual proxy and it should collect metrics, and that's it. So this, you can think about different styles, but it should be as easy as I shown it here, and how to get to this point, and how to cascade proxies, and how to do this stuff. So first of all, the difference between proxy and adapter, because I saw it so often that it's mixed, it's more or less an adapter is a wrapper, and this can be used to make incompatible things working together. It seems you have some method signature and it doesn't fit really well, and then you want to make it available for your new API. These are adapters, so they're changing the method signature. Here in this case, I have this legacy worker, something to do with strings. I'm using this old style with arrays, and on the other side, wow, this is slow. And on the other side, and on the other side, I have this working adapter that want to use, for example, lists instead of arrays, and then you can write this adapter. So you see that the adapter and legacy stuff you have is more or less hard bound in terms of that both need to know each other. So an adapter needs to know implementation details. It's changing the signature. It's changing the way of how to use the original one. And this is an adapter. This is not a proxy. Here, from array to string, it could be something, naming conventions, and so on and so on. Okay, so this is something that is definitely an adapter, but we want to have something that has the same signature instead of this one. And I think, so I think this is an easy explanation what an adapter is, and I don't want to go too much into the details. Okay, one interesting thing is that adapters don't need to be inside the inheritance. Proxies are always in this inheritance path, and this is one of the bigger things as well. Don't mix it up, so please don't mix adapter and the proxy. If you're creating something, then make sure that you're building first the proxy and then you're adding a new interface or reverse, but don't mix it up. So it will make things just harder. Okay, so we need to know the legacy work, or we need to know the old implementation. Otherwise, we can't create proxies because we have the same method signature and it's in some kind of inheritance. We can break it a little bit with dynamic object adapters later, but mostly you have some kind of inheritance here, and proxies are very easy to use if you have some kind of interface. If you don't, because you have this old legacy code, you have just abstract classes and so on, we have to think how we can deal with this so that we are not messing everything. Okay, so how to work with this? So the proxy, the easiest version is just a delegator. So it's fulfilling all the requirements to be a proxy, but without any new things or cross-cutting functionality or whatever. So we have this interface, maybe as a service with a method signature. We have an implementation, and the easiest and smallest proxy we can write that's fulfilling all the minimum requirements. It's just a service provider implementing the service and redirecting one by one to the invocation of the original implementation. Okay, so it's completely useless for sure. So we are not talking about if this makes sense, but this is a minimum proxy. And now with this, we can start working on stuff that we want to have. We have different kinds of proxies. So the proxy itself is just something to delegate, and then we have main groups of proxies. For example, the first one I want to show is the security proxy. You can replace the word security later with some other words if you want to give access, yes, no's, whatever. So how this is working. So mostly you have this proxy is the original one, and now we want to change something. So the behavior here is I just want to execute if it is allowed, whatever it means with being allowed. And the easiest implementation is here. You have this original implementation, you have some kind of code. It's not very secure for sure. It's just showing here how it works. You have some logic that is deciding it's allowed, yes or no. And then, and here's a critical thing, if it is allowed, it will invoke something, but what it will do if it is not allowed. Here, it's just giving replacement, some dummy or whatever. But if you're dealing with proxies, and if you're dealing with proxies that can change the flow in terms of there is a result, there is no result, you have to think about what is the adequate value that you are giving back here. So here, it's just some kind of message. It's not very interesting, it's not very useful, but it's just the first thing, same method signature, behavior. You could extract this if it is allowed somewhere, and then you have some other stuff. The next group I just want to touch is a remote proxy. The remote proxy itself is, if you want to split up the invocation from the implementation itself, where it's running. So you have this process borders, you have network, you have whatever in between. And here you have this remote proxy. And this means I have a dedicated piece of software here on my side. I can invoke it. And then I have to make sure that somehow this will be replaced. And this means mostly you have interface on both sides. You have this proxy from the client side, you are pushing data over the wire or whatever, and the remote service will execute it and it will give you some stuff back. So this is mostly for remote communication. It could be between processes, could be between machines and all this stuff. So mostly this is a technical challenge because you have to deal with remote communication, and this is mostly technical work. And you want to hide here the communication itself. This is the only task for a pure remote proxy. But having in mind this is mostly a technical thing, and I don't want to go to this marshalling, unmarshalling, whatever thing this is more or less. The way biggest part and the most powerful part of being a proxy, and this is where I want to have a dedicated view on, is a virtual proxy. And with virtual proxies, you can do so many things. First of all, what is a virtual proxy? A virtual proxy is something that will make sure that the implementation of the implementation you want to have is just created after the first invocation. Okay, you're invoking on the virtual proxy, and then you will create something, and then you will delegate. So it's some kind of resource management, resource allocation. But what can we do here? So here, if I'm looking at this implementation, it's the easiest one that I can think of. It's just I have the virtual service and the service implementing the same interface. I have a holder, and with the first invocation of the method, I'm just checking, do you have an implementation? Yes, no. If no, then create it and then just invoke the stuff. But here we have a bunch of challenges. So, and one thing is that I have to deal in which way I want to allocate resources, what's the strategy, how to create this. I have it tightly bound, the implementation to the proxy, and so on. So we want to see what we can do. First of all, this one is not thread safe. So it means if you have multi-thread environment, or if you're invoking several times, it could lead to different invocations. That's not nice. The next thing is here, this service implementation is hard bound to this proxy. And maybe I don't want to have it. I just want to have the behavior of being created later. And this fixed decision for an implementation should be extracted. So what can we do in core Java without any big magic is, oh yeah, and the new operator, it's how to create this instance. So we have several things we want to touch and want to make sure that we can extract all the different features in generic implementation so that we can reuse it. For example, here this if service is null and the creation itself, the new operator, is more or less the service factory. So how to create a factory, how to create an instance, so I can decide later what is a way to create it. So I see here, can virtual proxy and security proxy be implemented using Delegator? Yes, you can, but how to combine, for example, different proxies, I will cover in a few minutes. So be a little bit patient, please. Okay, so here I'm just extracting the way how to create it. Could be a new operator, could be some technology. So I have the service factory. The next thing is I want to have different behaviors in what is the right time to create and the right amount and frequency of creating new instance. And this is a service strategy factory. So it means I have to decide now how to create, not how to create, but what's the right time and how often I should create it. If I'm putting all this stuff together and I'm building a not thread safe virtual proxy, I would extract the service factory just with a new operator. That's an easy implementation. And this one maybe just with this strategy. If it's not there, create it. So I'm not winning anything with this implementation compared to the first one in terms of being thread safe or creating in different ways. But what I have already is that I have now split up the functionality on deciding and creating the stuff. If I've done this, then I can work on different features. For example, here the service proxy is just implementing it new. The new strategy is just the strategy of decide its right time, and then the proxy itself will use these two different implementations to decide, okay, it's now the strategy factory that is working on the real subject that will be created by the service factory, and then invocate all this stuff. So now we can start splitting up this stuff. And now what I can do is the service factory to decide, okay, what's the right time I can extract, and I can start reusing it. We will see it in a more generic version, a new generic way a little bit later. And the same with the strategy. Okay, so if I have this one, how to make an example for a synchronized one is quite easy. I'm just reusing the service factory, and instead of this equal null, I'm just making this stuff synchronized. It's not fancy, it's not very effective, but it shows you that with easy implementation changes, you can have dedicated behavior here. So here it's just with synchronized, and that's it. Okay, the same is if you want to make sure that you have an implementation maybe and you want to invoke it free or fresh every time you're invoking this stuff because the old implementation has, I don't know, some leaks not working well. You can have something like a method scoped as well. You're using the same implementation, how to create it, but here you're just creating it with every invocation of this. So you have completely different behavior, and the implementation is always focusing just on this partially functionality so that you know what you're doing, and then you can test this one, then you can start combining this. That's the first thing what we are doing here. So, and then you can do a lot of stuff, but proxies are not alone in the world. So how to combine proxies? If I now can split up the implementation of the different functionalities of a proxy, the next thing is how I can cascade proxies to implement more complex features. For example, here, the first question is, these are always a security, a remote, and a virtual proxy. But if it is okay to combine them in a random way, I would say, no, it makes no sense to have a remote proxy going on the other side, creating a virtual proxy, and then identify, oh, it's not allowed to even use this method. So it makes no sense, this order. The other one, creating a virtual proxy to decide after this, okay, it's not allowed, and then going remote makes no sense at all. So it is really important to see if you are chaining proxies, that the order of these proxies are making sense. And this is reflected in names. So the first version is a security remote virtual proxy, so that everybody knows, okay, from the way of wording, what is done. Now, just combining two proxies before we are making it more complex, a security proxy and a virtual proxy, how you could combine it here in this way. What you're doing is just, we have this virtual proxy as we know it, and we are creating this with the first invocation. So, okay, there's a virtual proxy. And inside the security proxy, so check first if it is allowed to invoke this one. We are just using here the virtual proxy inside, and then we are doing our stuff. But these proxies are hardwired, and it makes no sense to implement all this proxy just to wire them hardly together, because then you're losing the flexibility, and you want to make sure that all these proxies are generic enough in a way that you can combine them without really coding the stuff. what we need now is some kind of a generic proxy. And since a long time, JDK 1.3, we have it. We have the dynamic proxy and what we are doing here. So with the dynamic proxy, we have some pros and cons. And I see it still these days that in projects, they are not really good use somehow. So what we have is Java-lang reflect proxy. We need an interface. Here it's called service, and we need an implementation here called service implementation. And then what we are doing here is this piece of code, and it's definitely too much. So we are going step by step through it. So the first thing is we have this service class cast. So we are casting to the interface, back to the interface at this point. The next thing is that we want to create a new proxy. This proxy class has a static method, new proxy instance. And here we need the class loader. The class loader we are grabbing here, for example, from the service itself. Then we have an array of implementation or interfaces we want to have use for this proxy. Here I'm just using one interface. And then we have this invocation handler. This is a piece of code that will be invoked if I'm calling this virtual proxy. And here what I'm doing, I'm creating the service implementation and I'm invoking it. That's it. The invocation itself is done via reflection, and this makes it a little bit more generic. But we have some pros and cons here. First of all, how to make a virtual proxy. How to make a virtual proxy is quite easy. I'm just using the invocation handler, and here I have this placeholder. I'm using the strategy. I use here for this example just a short version. We would have it with the strategy factory and so on. And then I can use this one. So that's it. The next thing is how to make it generic, because here I see so many definitions of types and all this stuff. So first of all, this service and this service is here used several times. So this we can get from outside. The next one is implementation. The implementation is here from somewhere. We have to remove it, and the invocation here, we will get this instance from a dedicated part. So how to make this one, so that we can use the dynamic proxies instead of writing them down. So for this, we can create some kind of proxy generator. This proxy generator will be this element that will give me this implementation in a generic way, so that I can use generics to create this dynamic proxy on the fly. Here, all this green stuff is a subject, and this, okay, yeah. So this one is just the invocation handler written in plain old Java. You see the subject will be get from outside, and the real subject that will be used is coming from outside. So now we can start combining this one. I can use the same stuff with lambda expressions. It's just a syntactical thing. I'm not going in detail of lambda expressions. I think the most of you know this stuff already quite well. So what we are doing with dynamic proxies, if I'm thinking about, okay, I have this strategy, I can make it now a little bit more in a generic way. We are writing less but more generic code, and we can create with dynamic proxies all kind of proxies we want to have. But the question is how we can make this a little bit more comfortable, and what can we do to combine proxies. So we have to switch from factory method pattern more to a builder pattern. And this builder pattern will give you some possibilities how to use proxies in an efficient way. So if I want to create a security virtual proxy, then I have two possible ways to implement it. I can have one security proxy with two rules and one virtual proxy, or I can have two dedicated security proxies, everyone for one rule, and then one virtual proxy. So how to implement it? I would always go with one functionality per one proxy, but what we need is something like a cascaded proxy. So we need now a chain of proxies to make sure that this code is not melted down in one proxy somewhere hardwired. Okay, so we have different ways to build chains of proxies. We can do it bottom up or top down. It depends what you're more comfortable with and what you have first, and what's your strategy, what you like, and so on and so on. But a child must know his parent so that you can always redirect. And we want to add different dynamic proxies in the first run, just always with the same target interface. We will make it more generic later, but first assume we have just one service, and we want to have it here as example. I want to dedicate a bunch of security rules, but in terms of proxies. So I have this interface security rule. The implementation, how to make sure, yes, it's allowed to do it, yes or no. Okay. And this is implemented as a functional interface, makes it smooth with lambda expressions, all this stuff. To collect all the security rules, I can have here this list of security rules, just, okay, the order, this should be checked. And then I can make it forward or backward, what's better for your needs. So how you want to use it. Okay, so I have now a list of security rules. Then I can iterate all this list. And what I need is the possibility to create now this dynamic proxy that is cascading all this stuff here. The gray stuff is just what we had from the dynamic proxy itself. And then the invocation handler is dealing with cascading proxies in a way. So here, what we're doing, we are iterating of the whole security rule list. And then I'm always holding from the proxy builder, the last original, holding this one. I'm invocating with this rule, check rule, this stuff. If it fits, okay, I'm invoking, sure. But then I'm switching back to my original. There's the last line, this cloud cast next proxy. So what I can do is now I can start cascading these proxies in a way that I'm defining what are the rules, what are the right order. And then I'm just creating with this behavior, with this proxy builder, cascaded proxies. So instead of manually wiring it, I have this behavior that I have from outside, the necessary stuff that I want to do, and then I can start it. So there's the last child. This is how to work on this child. So I'm invoking this stuff, and here I'm just going back and setting the child for the next level. So what I have is just a linear list of proxies that I can cascade. Okay. How this will be used is not so complicated. I have my class, I have my logic. I'm using now this proxy builder. I'm creating this builder with an interface and the original I want to have. And then I can start building these methods around. And with this, I can use inside this add logging, add matrix, add security rule, for example, very cool security rule, just true. But I can start building now this chain of proxies of the same interface that is in the end leading to the same implementation, but with different behavior. And then I can, inside this builder, can make sure that whatever order I'm using here with add logging, matrix, and security, that internally the logical good way of cascade will be built. So first the security, then maybe logging, then matrix, whatever. So whatever fits to your needs. And then if it is none, I'm just creating this proxy. So what I've reached now, I can add different functionality in an atomic way behind. I can make sure inside this builder that I have always an order of proxies that makes sense for my project. And I can decouple the definition during this builder or builder invocation from the point of time where I'm allocating the resources. So many things are reached already with just a few lines of code. Okay, but until now we had only a cascade of one interface, but how to deal now with different interfaces. And this is something I call NestedBuilder that you can use perfectly together with things I want to highlight in a few minutes. So let's assume we have this engine, and this engine here, or this car will have an engine, will have a wheel. And so you can imagine if you're building in the straightforward way with builders, then you would have something like this. The car, okay, you have a car in your builder with an engine, you have this instance of an engine with a wheel list, you have some kind of wheels, and then you're building this one. If you're using your IDE normally to create these builders, it would end up in something like this. You have an engine, your builder with attribute A, B, C, and build, and then you have this entity. Here, this list of wheels is a semantic break, more or less, because I need a list of wheels. So I have this list of wheels, then I'm adding a bunch of wheels, and this wheels should be created wheel by wheel with, oh my God, I'm creating builders again. Okay, so if I have all this stuff, by the way, there's an Italian car with just 3 wheels, means that even in this builder approach, you can start adding rules to validate if you have the dedicated amount of entities you really need if you have collections and all this stuff. Okay, just rewriting this stuff a bit means I'm creating the entity of engine, then the wheels, and I'm wrapping it in a list, and then I'm building this with a builder. So this is not nice code, definitely not. Okay, so it means that here I want to make sure that I'm minimizing the amount of code, and later I want to combine it with proxies for functionality we want to add. But the first thing what we need is we have to make sure that this syntactic not working in the same way. So it must be recreated in a way that it fits together. So if you're dealing with different builders and you have something in between this chain that is not a builder, make sure that you're creating a builder first. So this is overhead in the beginning. But now with this wheelless builder, I can start thinking about how to combine these builders in a way that I removing this boilerplate code and all this stuff. Okay, so, next one is I want to combine this one because this is not nice. This is very repetitive, and I want to see how I can combine this in a type safe way. So, okay, if I want to have this one, I want to create something that is more like I want to get rid of this and this. Oh, wait, too many animations. I have to remove them. So I want to have something like this. I want to have the way that I'm coming from one builder, here's a wheelless builder. And if I need a new entity, I want to have something like add wheel. Then I have just the methods that I needed to create wheel. And if I'm done, I want to switch back to my wheelless builder. So here I'm now switching between implementations. I'm switching between builders because here I'm a wheel builder and here I'm back to my wheelless builder. Okay, about the wording and all this stuff we can discuss endless, so it's not a perfect naming, but I hope it will show what I want to do here. And now I have to do it with all the others. So because then what I have is I have a complex builder that gives me the possibility to create different entities in a way that I need it. I can control it. I have full IDE support because it's core Java. I just see with auto-completion what methods are available. So I want to get rid of this one, I want to get rid of this one and the next one, because I want to have something that is just in one way usable. Here, this one. So I want to have a car builder. And if I say add engine, I will have just the methods to add my entities. I'm switching back, then I'm wheels, wheelless builder, and so on and so on. So this is code. As an object-oriented coder, I would like, because I now have my IDE completion on this stuff, and how to implement it. For this, I need just an abstract class, nested builder, with 2 types, and I have this abstract method build. All builders have this method build. It's a naming convention, and I have a parent. I need someone that is calling me, and this nested builder is then in a way to combine a tree of builders. So yeah, that's a parent, and the parent will connect itself. So it means I'm a parent, I am a car, I know that I need an engine, so I will add an engine builder, and I'm setting myself as a parent, because if you're done, I'm just switching back. Okay, so the next thing is the nested builder itself, the method done, just to have a different name. And here I'm getting the class from the parent, and with the naming convention, here the green one, I just make sure that I know how to set myself. Okay, so, and then I'm using exactly the same what I'm doing inside the dynamic proxies. I'm invoking the method with reflection. So what I'm getting with this is that I now can connect, myself with my parent. So I can go back during the time I'm done. So I'm invocating myself. Okay, I'm done. My instance is created, and now I'm setting myself. So if you have this one, then we have the parent builder will hold the child builders. Okay, I have now this add child method to delegate to the next builder. And from this, the child builder just has to extend the nested builder. That's it. Yeah? And then I can start with all this stuff. Okay. This is boring code for sure. I'm writing it once manually. So I have my parent, I have this attributes, and what I have to add inside the builder is just the holder of the new builder and setting myself with this. And the next thing I need is just a method to offer this new builder. Okay, if you're looking at this code, you see this is easy to generate because it's very symmetric code. Okay, switching backward and forward. Okay, and the nested is just, the child builder has just to extend nested builder. That is with the typing. So altogether means this is very, very good to generate. And I reached something. I can have a parent with kids, but I can be a kid and a parent at the same time. So now I'm able to create a tree of builders, and this in a type-safe way. But going back to the combining proxies, I have now the security remote virtual proxy, and I want to make sure that I'm creating all this stuff. I can use now for this cascade of proxies, this cascaded builders in an easy way to give a subset of proxies, and my colleague can easily use it. Okay, so one functionality leads to one proxy instance. This issue, don't mix different implementations, runtime overhead for every proxy. Yes, for sure, you have some CPU cycles, but we can optimize it later. So make sure that you're not optimizing in the beginning. So then we have the possibility not only to mask a whole object, we can do it on a method base. The first original version was written by Heinz Kabutz. It's called DynamicObjectAdapter. And what we are doing here is we have this proxy, and it will decide on every method if you're calling the original or if you're calling an adapted method. Okay, so now what we can do is we can now build proxies that are selecting implementations on method level. So yeah, how to identify a method. The first thing is, oh, that was so fast. So, back. So this one. So assume we have an interface to work A, and then we have this implementation with the same method. And then what I want to have, I want to have method identifier in Java. It's enough if I have the name of the method and all classes from the parents. With this, I can just build this method identifier with equals and hash code, and then I can identify every single method if I'm dealing later with reflection and all this stuff. Okay, so the first implementation was that I have this invocation handler. I have all adapted methods in a hash map identified by this method identifier and an original. And the adapter here, it's called object because we have challenges with typing and all this stuff. Okay, if you want to add an adapter, you're adding this object inside. You will find here this methods you want to override on the fly. So you have this adapter, you're getting the class, you're getting all declared methods, and then for all methods, you're identifying, creating the method identifier and putting this into the method of adapted methods. So inside one implementation, you can select a bunch of methods you want to adapt, and that's it. And then you're invoking this stuff. And here, yeah, I'm doing just the same with this, yeah, what I've done with reflection. Okay, so next one. To invoke this one, I'm creating the method identifier. After this, I'm grabbing it exactly the method here to this one here. I'm getting out the method I want to invoke. And then if there is something, I'm invoking it. Otherwise, I'm just using the original. So that's it. So now I'm switching here between implementations inside an object on method level. So, okay, how's this? Exception handling. So what could be a problem here? What could be improved? The first thing is more or less that if I have a service and I have different adapters, it could be useless because I'm just refactoring over the time. And if I have this type object inside to adapt methods, I'm adding useless adapters that never can be invoked, but it's hard to find them because there is no compile error and all this stuff, okay? Because I'm just renamed it, all this stuff is working. And I want to get rid of this. So I want to switch between implementations here. So the first extension could be in a way that if I have a service with two methods, for example, and I have an implementation with these two methods, what I can do is I can create for every method an interface that's just holding this one method reference, this one method definition. With this one, this mostly function interface, so I have all this lambda expression stuff then available. And if I have this one, what I can do is I can now extend this dynamic object adapter in a way that I can have adapted methods and adapters for several methods with different implementations. And later I will show how to make it type safe. So adding adapter is still an object here. Then I'm getting the class, the declared methods for all methods, creating a method identifier, adding this to this hash map and the adapters for this. And later, after adding these adapters, I can do it with different. The invocation is straightforward. Creating the method identifier for the method, checking if I have an adapted method. If I have it, then invoking the adapter. If not, invoking the original. So with this, I'm now able to split from one object with a bunch of implementations to dedicated implementations. Okay, but we need something more, because here this object is still here. So if you're using this without a builder, you can still add useless adapters, and this makes no sense, or we want to get rid of this. So how to do this? If you have now the possibility to have this builder to add methods, what you can do is for every single interface you created, you can create a method with method name A and B, and adding exactly this service adapter for this one. So just for this method signature. If you're compiling this one and the method signature don't fit, it would break. Okay, so we have these two methods, and then we can create this interface. If you're looking at this one, this is a very symmetric thing, and you can create this stuff very easily. Okay, how to use it? First of all, you have this adapter builder typed, and you're creating a new builder. We have this generate builders already with a target interface. Okay, this is my target interface with an original. Okay, here's the implementation I want to delegate through, and then partially I can override the behavior of this one. Okay, and then I'm creating. If I just want to use a mock because I'm partially testing things, then I'm just giving an original null, and I'm just working on the implementation itself. Okay, we can discuss now if you want to use this straight, but it will explain you how you can switch between implementations, how you make a composition of implementation, or how you can make partially proxy for legacy code if you have this huge methods and you just want to add functionality on several methods. So this is way too much boring code, and you want to have type safe version. And if something's wrong, you want to break a compile. And the easy thing what you can do is here, if you have these interfaces, we can create this functional interfaces out of it, because all the information we need, we have in static semantics. I can go with all this interface and extract all this information. It means I need some naming schema. This you can do in a way you like. Okay, for this we can use annotation processing. You can mark something with add DynamicObjectAdapter-builder, and then you can create all this stuff. Okay, and then yeah, well, you need it on source code level so that you can have it during the compile phase. But then you can create the whole builder, the whole cascaded builder, all the proxies, all these dynamic adapters you can create, and this is well, very powerful tool if you like annotation processing. Okay, good. If you have this, I'm looking a little bit on the time. We have to speak a little bit fast because time is running out. If you don't want to make it with dynamic proxies, as I shown before, you can do the same without this runtime overhead or with less runtime overhead with static object adapters. It's more or less the same strategy. What we're doing here, we're splitting all this stuff. We have these different methods. We're creating these interfaces, and instead of building dynamic proxies, we can start implementing it on the fly. And this static object adapter is just holding the original, having adapters for every possible method, and a method will be masked with, do you have an adapter? If yes, work on this one. Otherwise, take the original one. So this can be created during the compile phase again, and then you have the static object adapters. So the possibility to mask on a method level with static semantics or with a compile, instead of doing this dynamic proxy stuff. Writing annotation processors is not everybody's favorite thing, but it could be done. So, okay, and then you are adding this just with add static object adapter. So, what have we reached so far with this? we have, first of all this stuff is here on GitHub available. So if you don't want to type this, if you want to try it, or if you want to have some ideas how to implement these different proxies, then you can go to my GitHub repository and grab this proxy builder stuff. And an implementation that is using this one is this dynamic dependency injection. Is some kind of dependency injection with dynamic reconfiguration on runtime base with metrics, but different thing. It's just where I use this one. The main thing is what we learned is I can first of all split up the implementation and the strategy how to create and how often I'm creating interface with this strategy factory and this implementation factory, so that I can create strategies in a generic way that I can reuse during the time I'm coding proxies. If I don't want to code this manually written proxies, I can use this dynamic proxy as an old thing in Java, but here you have this reflection and this runtime overhead a little bit. And on the other side, if you're dealing with proxies, make sure that one proxy is just fulfilling one dedicated task. And this means you have immediately to deal with how to cascade proxies, how to make sure that the cascade of proxies makes sense. And for this, just use a builder pattern. With a builder pattern, you can make sure that you are sorting the proxies in a logically good order, even if you are adding them in a complete random order. Okay, and you can create proxies at a different time as you are using the proxy, and you have to allocate the original one. Okay, or the original implementation. On the other side, if you want to make it more complex, if you have a tree of, for example, you have a huge tree and you want to make sure that you have with virtual proxies, for example, or with dedicated metrics inside a complex object, you can split it up that you're building for every single object you build for sure, and the proxy if needed, but you can do it in this more complex tree. This was a nested builder approach that you have the possibility to have this type safe and this straightforward way that the IDE will give you the possibility to work on how to create this complex proxy. So, and the last thing was, if you have this old legacy code and you just want to override one implementation, you can go with this dynamic object adapter approach. The first one is just having one adapter that holds a few implementations that's not compile safe or refactoring safe, and you have to implement all the methods in one object, but you can extend it in a way that you have just this function interface, so that you really have this one method with this function interface, and then you can combine it during the runtime without changing the original. So even if you have just for dedicated amount of minutes, some functionality you want to add, some metrics or whatever, then you can adapt it, and then you can remove it without bytecode manipulation and other tools, if it is, for example, not allowed in your environment. And then you can make it in a static way with the annotation processing, so that you're doing exactly the same, but on a static level. So everything can be done with Core JDK stuff. So you need nothing else, no additional library. Everything is part of the JDK. It depends a little bit on what JDK you're using, how nicely you can work with syntactical stuff. So, and generics slightly change between the generics, but it really depends what JDK you want to use and what's the minimum you use. But everything I showed here is working since JDK 8, definitely. Without lambda expressions, you can do it even previous JDKs. I don't know if one of you has to deal with this, but yeah, that's more or less all of the stuff. So now, checking here the chat. So I have a question here. My understanding is that with a decorator, you have to pass the object to be decorated. The type and the behavior of this object would be known at compile time. Yes, but with a proxy, that is not necessarily the case. A proxy could create thing to be delegated dynamically. Yes, proxies can be used for way more dynamic flow inside. So you can activate at runtime behavior. You can deactivate it without bytecode manipulation. You can change the flow, definitely. So you have a lot of possibilities with proxies if you want. And for sure, it depends on your needs inside your project. If you want to have it in this dynamic way, yes or no. So, but the good thing is just pick what you need, combine proxies with all the other design patterns you have. They're very, very powerful. And if you are using proxies in in an efficient way, you can reduce a lot of boilerplate code with proxies, because you can extract functionality and strategies there. Okay, any other questions here? Oh, by the way, was I able to give an answer to your question, Mark? So otherwise, perfect time for questions. Oh, here's the next one. I think it was mentioned earlier, but just to confirm, will this talk be uploaded to YouTube later? Yes, I think this will be uploaded to YouTube. And by the way, I really love to have more subscribers on my tiny YouTube channel. So please have a look at my YouTube channel. It's the Outdoor Minus Nerd one. So select the English one if you find it under my name, Sven Ruppert. And I would really love to have a few subscribers there. It's my pet project, more or less. And yeah, okay. So if you have any technical questions, feel free to ping me on LinkedIn, Twitter, whatever you like. Don't use email. Please don't use email, because email is just a black hole where everything is coming in and it's way too much. So please try to use something like Twitter, LinkedIn, whatever. Okay. So, and maybe if the big C is, yeah, not so aggressive, and we are able to travel, maybe we can do this like live hacking some days. So feel free to think about if you want to have it at your jug so that it can be there and we can do all this stuff for a few hours. And if you want to have additional topics, I have a few more things about supply chain security for software developers. So if you're interested in this, check out if you want to have a second slot, maybe in a few weeks or months, then we can talk about supply chain security topics for pure software developers. Okay, so I'm done.
Brill.
And in time.
Perfect, well done. It's always the hardest bit, isn't it? Because it's so interesting and so exciting to talk about that you kind of go, oh no, I've run out of time. Well, thank you so much. Am I right in thinking there's a QR code for us to enter the raffle? Did I hear that right? Am I being a bit dense?
There was something. I think Ari had it in the beginning in the chat.
Yeah. Yes, actually, people definitely have been entering, which is awesome, and we will select the winner within 2 business days. If you look up top of the chat, what was that? No problem. I'll put it. Let me put these links down at the bottom for those who may have come late.
Thank you.
So because the raffle link is going to close probably in the next few minutes, but there's a last chance to enter. There's 2 and definitely will be allow a few weeks for the t-shirt just because of COVID, but if you entered your address, you will get a JFrog t-shirt as well. Okay. But we'll announce the winner once the winner formally accepts the prize once they're selected.
Fantastic. Thank you, guys. That's amazing. And yeah, just to say for the YouTube video, if you want it, like I said at the start, but you may have missed it, it will be available on our YouTube channel. So look for RecWorks on YouTube and you'll find it, or you can send me a little message on LinkedIn. I'll put my profile back in the chat as well so that you can find me, and then I'll be able to send it as well. Just ping me a little message and say, hey, can I have Sven's talk? And I'll be able to send it to you. So that would be fine as well. When I get there. Trying to multitask, it's terrible, isn't it? There we go. Cool. So there's nothing else for me to say except thank you so much, Sven and Ali and JFrog, for today's event. It's been amazing to be here. Thank you so much to everybody who's joined us today. It's been really great to have you as well. And we're really looking forward to our future events with you guys as well. So thanks very much. Have a great afternoon.
Thank you.
Yeah, massive thanks for that. That was really interesting.
Excellent.